Okay, today we're going to talk about adding and subtracting with scientific notation. So there's going to be two different situations where if you have the same power of 10 or different powers of 10. So when you have the same power of 10, to add and subtract values written in scientific notation, the numbers must have the same power of 10. If the powers of 10 are the same, simply add or subtract the numbers out front and keep the power of 10. We're going to skip the next part for right now, and we are going to go to the first example. So when they have the same, all you have to do is add the number out front. So we have 6.2 times 10 to the 8th plus 2.3 times 10 to the 8th. So these are the same, so we simply just have to add the number out front. 6.2 plus 2.3. I'm going to repeat that so we know that's what it is. And then you add them. So 2 plus 3 is 5. 6 plus 2 is 8. And 10 to the 8th power stays the same. So there's your answer. And then we're also going to do this example over here. We're going to subtract. So we have 9 times 10 to the negative third minus 4 times 10 to the negative third. So if you notice, these powers of 10 are the same. They're both negative 3. So we're just going to subtract the numbers out front. So 9 minus 4. I'm going to repeat this just so I don't forget what it is at the end. 9 minus 4 is 5 times 10 to the negative third. And this is our answer. 5 times 10 to the negative third. So now you might have a situation where you have different powers of 10. Because of place value, if the numbers in scientific notation do not have the same power of 10, you can choose to change one of the numbers, giving it the same power of 10. So you're going to have to manipulate your number to make it have the same power of 10. Or you can convert your values to standard notation and then rewrite in scientific notation. That, to me, sounds like a lot of extra steps. You can change one thing up here. So this would be one step. And then this would be almost 2 or 3 steps because you're changing both numbers. So to me, it would just make sense to change one. All right. We're going to do another example where they're the same, and then we're also going to do an example of where we have to convert. So again, these are the same. We have 1.9 times 10 to the negative fifth plus 5.42 times 10 to the negative fifth. So those are the same. So that means we add these numbers out in the front. 5.42 times 10 to the negative fifth plus 1.9 times 10 to the negative fifth. So we're really just going to add these numbers right here. There's an imaginary 0 here. So 2 plus 0 is 2. And then 4 plus 9, 13. Carry my 1. 1 plus 5 plus 1 is 7 times 10 to the negative fifth. There we go. All right, so for this example, We can convert them to scientific notation, or we could just add it together. I think it's easier to just add in scientific notation, so I'm going to convert both of these. So start after your decimal. 1, 2, 3, 4, 5, 6, 7. So we have 4.5 times 10 to the 7th power plus 1, 2, 3, 4, 5, 6, 7. 2.3 times 10 to the 7th power. So if we add these together, our 4.5 and 2.3, we have 8, so 6.8 times 10 to the 7th power. All right, I'm going to let you do the other two on your own. I am going to move on. We're going to do some examples where they're different. So here we have 4.7 times 10 to the negative times 10 to the 7th and 3.4 times 10 to the 6th. So they're different. What I'm going to do is I'm going to change, and it doesn't matter which one you change, but I'm going to change this one, move my decimal over here so it's 0.34 times 10 to the 7th power. So now they're the same and I can add 4.7 plus 0.34. We have a 0 here, so we have 4, 10, carry my 1, 5.04, and it's 5.04 times 10 to the 7th power. All right, next example. 9 times 10 to the 5th power minus 8 times 10 to the 4th power. So we have different signs. I'm going to pick one to change. I think it might be easier to change this one. You can do the other one, but I think it'll be less steps to change that one. So I'm going to move my decimal over one place. So it's 0.8 times 10 to the 5th power. So now we have 9 times 10 to the 5th power minus 0.8. Actually, I'm going to erase this part so we can 0, 0. Actually, don't need that. Make this 10. Take from here. We have 10 minus 8, which is 0.2. 8 minus 0. So we have 8.2 times 10 to the 5th power. If you were to change this one, you would have to convert it to proper standard notation after, or scientific notation. So you would get 0.82, and you would have to change it 1. All right, let's do another example. The negatives tend to be a little more tricky. So we have 2.8 times 10 to the negative 5th plus 5.4 times 10 to the negative 6th. I'm going to change my 5.4 and I'm going to make it 0.54, and since I'm taking a decimal and moving it to the left, it's going to be -5. So 2.8, and that's where it gets tricky, is trying to figure out what your decimal or your negative changes to. plus 0.54, 0.54. Go ahead and add those. 4. 8 and plus 5 is 13. Carry your 1. 1 plus 2 is 3 times 10 to the negative 5th. And that is our answer because that is correct scientific notation. All right. Next question. We have 7.2 times 10 to the negative 3rd and 6.8 times 10 to the negative 4th. I think I'm going to change this one again and make it negative 3, so I only have to move my decimal to the left 1. So we have 7.2, and then we have 0.68 times 10 to the negative 3rd. So 0.68, subtract those, and we'll get 10. We have to borrow from here. 10 minus 8 is 2. Borrow again. 11 minus 6 is 5. And 6 minus 0 is 6. So 6.52 times 10 to the negative 3rd is our answer. Okay, so you can go ahead and try the following 4 problems and the 2 from the other page, and then check your work with the key in Schoology.